Hello, everyone. This question is converting a recurring decimal into fraction. We see the method how to change a recurring decimal into a fraction. Now, they prove algebraically that the recurring decimal 0.12 dot can be written as the fraction 11 over 90. So the method we do here is we let x to be this decimal 0.12 dot. Then we times this value of x by 10 both sides. So we have one equation. So if I times both sides of this equation by 10, then I have 10x is equal to 1.2 recurring. If I times again by 10, so I have 100x, then the number, it will be 12.2 recurring. And now if I need to find a way to eliminate the recurring decimals, and they can be done by subtraction. If I subtract the first equation here from the second, you see that the recurring decimals, they cancel out. So we have 90x is equal to 11, and then dividing both sides by 90, we have value of the fraction as 11 over 90. The other question that we're going to see is finding the upper bound of a fraction. If the numbers have been rounded, if you see this example on the screen, here we have a fraction a over b. The numerator of the fraction a is rounded to 1 decimal place, and the denominator is rounded to 3 significant figures. So, given that the numbers have been rounded, to find the upper bound of this fraction, then we need to find the upper bound of the numerator a, which is 4.35, because the rounding is done in 1 decimal place. And the lower bound of denominator b is 3.455, because it's rounded to 3 significant figures. Remembering the two methods of how to round to 1 decimal place and how to round the numbers to 3 significant figures. And then we can find the lower bound or the upper bound of the fraction by dividing the upper bound of the numerator a by the lower bound of the denominator b. So in this case, we get the bounds of the numerator, which is 4.35, the higher bound, divide by the lower bound of the denominator, which is 3.455. And this gives us the upper bound of the fraction a over b, which is 1.259. So this is the second example on how to find the upper bound of a fraction when the numbers, numerator and denominator, have been rounded to 1 decimal place and 3 significant figures respectively. Now the next exercise is finding combinations of a number. Show you an exercise on, here we have Nina needs woolen hats to sell. She has 6 different colors of wool and can choose from 4 different patterns. Each hat is made from 1 color of wool. So how many combinations of styles can Nina make? So you have 6 different colors. So you have number of colors are 6. And number of patterns are 4. To find the different type of combinations we can make using colors and patterns, we times the two numbers. 6 times 4 is 24. So the answer here is 24 different combinations. This is always the case when I have two combined, or to find the different patterns and different type of combinations. We do multiplication of the two numbers, 24 different styles in this case. This is not difficult question. The next one that I will show the method is adding a mixed number with a fraction. To add a mixed number and a fraction, it's necessary to change the mixed number into a fraction. Now the exercise 2, we have a mixed number 2 and 2 over 5 plus 3 over 4. It's necessary here to change the mixed number into a fraction. So the way to change this into a fraction, we times the number 2, the integer 2, by the denominator, and we add the numerator of the fraction plus 2, and I divide this by the denominator 5. So the mixed number can be changed into a fraction as 12 over 5. I can't simplify more, so I can keep the fraction as 12 over 5. Now I can add the two fractions now separately. So we do 12 over 5 plus 3 over 4. Now, if you remember the methods of previous mathematics, we need to have same denominators. So we need to change the fractions into the same denominator, and the lowest common multiple between 5 and 4 is 20. I always choose the lowest common multiple for the common denominator. I choose the lowest common multiple between 4 and 5. In this case is 20. Lowest common multiple is the lowest number that both numbers can be divided by. So in this case, I times this, and I found 20. Now changing the first fraction into an equivalent fraction with 20 in denominator, I times both numerator and denominator by 4. So I do 12 times 4 divided by 5 times 4. And then I also need to change the second fraction into 20 denominator. So in this case, I need to times by 5. So I do 3 times 5. These are equivalent fractions. And if you see, both now have same denominators. 12 times 4 is 48, divided by 20, plus 15 over 20. Since both of the fractions have same denominators, I add the numerators, and then the answer is 48 plus 15 give you 50, 63. 63 over 20. If I want to convert this into a mixed number, I check how many times 20 goes into 63. It goes 3 times. The remainder is 3, and the denominator is always 20 here. So the answer is 3 and 3 over 20. And this is the simplest form because I can't simplify the fraction anymore. It can't be simplified more. So this is the simplest form. So remember, if you have a mixed number, you need to change this into a fraction using this method. So let's say the mixed number is A, B over C. The way we change this, we times A by C, A times C. We add them B, and then we divide the whole fraction by C. And this is what I did here also. I changed the mixed number into a fraction, and then when you have two fractions of different denominators, you need to change them into the lowest common multiple. And remember the methods of equivalent fractions. To find equivalent fraction, we times both numbers by the same number. Okay, the next exercise is standard form. You need to be able to work with standard form. So in this exercise, they will have a fraction and addition of fractions, addition of numbers is standard form. And in order to simplify this fraction, you need to add the numbers on the numerator. So it's a good idea here to simplify the numerator. And there are two ways of doing this. Either you change the powers as you make the powers of 10 the same, so you can do like terms, or you can change them, you can make them whole numbers and then change into standard form. I always choose the first method. I think it's easier. So if I want to add the two numbers, I need to make both as powers 10 to the power of 4. So all I need to do is to change the second as I times the 10 by 10 and I divide 5 by 10. So it's 0.5 times 10 to the power of 4. Now I can change this number into this because now I have 10 to the power of 4 and the first number is 10 to the power of 4. So I can use the method of standard form. Now the fraction that I need to use here is this one. So I have 3 times 10 to the power of 4 plus 0.5 times 10 to the power of 4 divided by 2 times 10 to the power of -3. Now, if I check the numerator of the fraction is the number above the other one. So this is the numerator, in case you forgot numerator. And the other number is the denominator. So since they have the same powers, they are like terms, so I can add them as 3 plus 0.5, so it's 3.5 times 10 to the power of 4 divided by 2 times 10 to the power of -3. Now, to simplify this fraction, I need to remember, I need to use the indices law, the indices rules. Remember, with division, we subtract the indices. So in this case, the fraction is 3.5 divided by 2, and I can use a calculator. So 3.5 divided by 2 is 1.75 times 10 to the power of 4. Because I subtract a negative power, the power changes into a positive sign. So I have 1.75 times 10 to the power of 7. And this number is in standard form because the 1.7 is higher than 1 and lower than 10. So it satisfies the conditions. And also the power of 10, and then the other is a power of 10, which is also true. So this is in standard form. And that's all I can do here, nothing else. And this is the answer. Give you your answer in standard form. A number is a standard form when I express this in the form a times a power of 10. Okay, the a need to be a number between 1 and 10, and the power can be either positive or it can also be negative. And this satisfies the conditions of a number to be in standard form. So it can be positive or negative, the power. Negative power means division, because you find the reciprocal of the number and you divide. If you have any more questions, you can leave a comment. So let's go to the next exercise. The next exercise is finding percentage increases. Finding percentage increase of a number. Now in this exercise, we have numbers that change. Okay, so the height of a plant has increased from 8.2 to 12.6 in a month. To find the percentage increase, we need to find the percentage increase. So the formula, normally the formula to use here, if I have a number A changing to a number B, I find the difference between the numbers. So I do B minus A, and I always divide by the starting value. So I divide by A. This will give me a decimal. So to make it a percentage, I times this by 100. So it gives me a decimal. So if I times this by 100, it gives me a percentage. So I follow this formula here. I subtract the numbers 12.6 to find the difference, and the difference is the change from the first to the second. So it's 12.6 minus 8.2. The difference here is 4.4. So it's 4.4. I divide by the first number, 8.2, and this gives me the decimal. 4.4 divided by 8.2, this gives me 0.53.6, 0.53.6. It's a recurring decimal, so it's 53.65. And then if I times this by 100, I can make this a percentage. So its answer will be 53.7, because I need to round this to three significant figures. 53.7. Remember, three significant figures, just to remind you the method of three significant figures. If I have a decimal 0.5365, I need to have only three digits starting from the left, non-zero, and the left side. So I draw the line at this point. Because 5 and higher, I make it rounded up. So I make it 53.7 here, and then this is 53.7%. Okay, so because I do rounding up here, because of the 5 here, because of this digit. If it's less than 5, I do rounding down, so I keep it 53.6. So it's rounding up. Okay, we have done also this exercise. So the next exercise, we need to prove algebraically that the recurring decimal can be written as a fraction. So we need to find a way to change recurring decimals as fractions. The method I use is to find a way to eliminate the recurring decimals. The decimal in this case is 0.23.4 . And I make this recurring decimal as x. Then I try to times both sides by 10. I times both sides by 10. So the right hand side is 2.3.4. Then I times another time by 10. So 100x is 23.4.3. Now I go and check whether I can eliminate the decimals, the recurring decimals by subtraction, but it's not possible because the decimals are not in the right position. So all I need to do is to times another time by 10. So I have 1000x. 1000x is equal to 234.3.4. Now, if you check now the two equations that I can use to eliminate the recurring decimals is this equation and this equation, because I see that they are in the right position. After the point, I have the 3 point, and here after the point, I have the 3 point. So subtracting the first equation from the second, I subtract the first equation from the second. And the way I subtract the left-hand side together and the right-hand side together. Okay, this is the way we subtract. We do 1000x minus 10x give you 990x. And now if I subtract the right-hand side is 234.3.4 minus 2.3.4. This gives you 232 exactly, because the decimals are 0. And now dividing both sides by 990, I can find this fraction. So dividing both sides by 990, remember the equations. So we divide both sides by the same number. So we have 232 So it's 232 divided by 990. Now to simplify this fraction, I divide both by 2. If I divide 232, this gives me 116 divided by 495. I can't simplify anymore, so the final answer is 116 divided by 495. This is how you change a recurring decimal into a fraction. So, and normally you have to find the right equation to subtract. This is the method to use. Number 6, we go to the next exercise. The next exercise is finding the lowest common multiple and the highest common factors between two numbers. And we use some rules here and formulas. If we don't want to use the Venn diagram method, there is one effective way of finding the lowest common multiple and the highest common factor between two numbers, especially if they have been, if are in prime factorization from like the above numbers. These numbers are in prime factorization. So the P is 2 to the power of 3 times 3 squared times 5 times 7, and the number Q is 2 squared times 5 squared times 7 squared. And find the highest common factor between P and Q. And to do this, we need to remember the formula how we choose the factors. Okay, the factors, the formula that we choose is good if you write them separately, the numbers here. P is equal to 2 to the power of 3. So you can compare the prime factors. 2 to the power of 3 times 3 squared times 5 times 7. And the Q is equal to 2 squared times 5 squared times 7 squared. For the highest common factor, we choose the common factors with the lowest powers only. Okay, common factors are factors that can divide both of the numbers. And in this case is the 2, the 5, and the 7. And we use the lowest powers. So in this case, I choose the lowest power of 2 is squared. Then I times by the next common factor is 5. The lowest power is 1. And then I times by 7. The lowest power is 1. Now the answer, I can leave this in this form, and it's acceptable form. So this is a 4 times 5 times 7. And this is the highest number that divides both of these numbers. To find the lowest common multiple, we do the opposite here, because the lowest common multiple is the lowest number that can be divided by both of the numbers. So we need, this number needs to be higher. Remember that the highest common factor is lower than the lowest common multiple. So to find the lowest common multiple, the formula to use is from the common factors, we choose the highest powers, and times by all of the other factors, by the rest. So if you see how I choose, this is the formula to choose the lowest common multiple. So the lowest common multiples here will be 2 to the power of 3. The common factors with the highest powers is 2 to the power of 3 times 5 squared times 7 squared and all the other factors. So you need to use the 3 squared here also. And this is the number that can be divided by both of the numbers. This is the definition of the lowest common multiple. It's the lowest number that can be divided by the other two numbers, and the highest common factor is the highest number that can divide both of the numbers. So this is have to be lower than this one. The other part is find the number 10 times q. But since the number q is in prime factorization form, I can write 10 also as 2 times 5 and use the indices law. So 10 is equal to 2 times 5. Using the factor tree, 10, I split the 10 as 2 times 5. And you can see that the q has an additional 2 and an additional 5. So it would be 2 to the power of 3 times 5 to the power of 3 times 7 squared. I have increased the powers of 2 and 5 by 1. We need to find the product of powers of prime factor. Now the 1 over 4p It's the same logic here. 1 over 4, I can write this as 4 to the power of minus 1. Now, because 4 is not a prime number, I can write the 4 as 2 squared, and this is to the power of minus 1. Using the indices rules, I can times the powers, and now the 2 is the power of minus 2. And I go and check now the p, the power is 3. So I go and add the indices. So the p needs to be in the form of 2, 3 minus 2 is 1, times 3 squared, times 5, times 7. Now the rule I use is a to the power of z to the power of k. Then I can times the powers here. This is another rule of indices that is very useful with indices. If I have a power raised to another power, I times the indices. And also another rule is a negative power. If I have a negative power, then I found the reciprocal of the number, and then I raise this to a positive power. And the opposite, if I want, I can also do the opposite and make this from here to go and make it a negative power. So the 1 over a is the reciprocal of the a. And basically we have answered this exercise. We wrote all the numbers as powers of prime factors, products of powers of prime factors. Prime factors are numbers that cannot be divided, like the 2, 5, 7, 3, because all the rest can be divided by other numbers. So we use this method of the factor tree. Factor tree is very useful here to remember how to find the factor tree of a number. And using the factor tree, you can find the highest common factors and the lowest common multiples using the above formulas. Okay, since I have another exercise that I need to show here, so the number 7 is finding an estimate of complex calculations. To find an estimate of a complex calculation, it's necessary to round the numbers to the nearest whole number or to the nearest square number, depending on the estimation. In this case, I can round the 5.34 as 5 squared. Because estimate, we don't even need to be accurate. So I round to the nearest whole number, so it's 4, and the next one is 2. And then I found the square root. So the answer here will be square root of 25 minus 8. This gives you square root of 17. This is an estimate of the above calculation. In the next exercise, we need to find the area of a right angle triangle. And we have the hypotenuse as 2 root 3, and the base of the triangle is root 3. To find the area, we need to use the formula of the triangle area, which is area is half times base times height. But we don't know the height, so it's necessary to find the height using the information in the question. So in this case, we can use the Pythagoras theorem. The Pythagoras theorem says that the square of the hypotenuse is equal to the square of the base plus the square of the height. And since I know the two numbers here, I can find the height by solving an equation. So the 2 root 3 squared is equal to root 3 squared plus h squared. Rearranging, first simplifying the sets, Now to simplify this, I raise both of the numbers to the power of 2, so it's 4 times 3. The third and the power cancel each other, so it's 4 times 3 is equal to 3 plus h squared. So 12 is equal 3 plus h squared. Subtracting 3 from both sides, h squared is equal to 9, and therefore the height is root 9, which is 3. Since I found the height, I can now use the formula and find the area in square centimeters. So the area is half times root 3 times 3. So it's 3 over 2 root 3. And that is the end of the exercise. So the next topic is the bounds. This is a question of finding the error interval or the bounds of a number when the numbers have been rounded. The bounds are the maximum or the lower values that this number can take. So here we have the formula for the speed as the distance divided by time. And then distance is be rounded to one decimal place, time has been rounded to one significant figure. Find the upper bound of s, the speed. Now to find the upper bound is the maximum possible value for the speed. Remember to take the upper bound of s, I need to take the higher upper bound of d, the distance, du, the upper bound, divided by the lower bound of t. So it's necessary to find the bounds of d and the t separately and take these values. So I try to find the bounds of distance. Distance rounded to one decimal place. So the lower bound of the distance is 132.35, and the higher bound of distance is 132.45. I do the same with the time. The time is rounded to one significant figure, so the lower bound is 1.5 and the higher bound is 2.5. So to find the upper bound of speed, we need to take the higher bound of the distance. So the speed is 132.45, and I need to divide by the lower bound of time, so 1.5. Doing these calculations give you the upper bound of speed. So it's 132.45 divided by 1.5. This gives you as 88.3 kilometers per hour. So this answer here will be 88.3 kilometers per hour. And this completes the question. Let's see the other exercise here. The other one is indices. Indices law. So remember the indices that have some special rules that we need to remember. So this is a cubic root. First, we have a cubic root. Now, in this case, is multiplication of powers. Okay, so it's now third. This is a cubic root. Let me remind yourself some rules of indices. Fractional indices. here it's useful to remember the fractional indices rules, fractional indices. A to the power of z over k. If I have a number raised to the fractional power, this can be written as a third. Then denominator is the degree of the root, so it's k, and the z is the power of the whole here. I can bring the a under the root, and I can raise everything to the power of z. For example, if I have a to the power of 2 over 3, I can write this as a cubic root because of the 3 denominator, and the 8 goes under the root, and this I raise to the power of 2. So the cubic root of 8 is 2, because 2 times 2 times 2 is 8. The root is the opposite of a power. So if I have to take the cubic root of 8, I need to go back and find what is the number I started with. So I started with 2. So this is give you a 2 to the power of 2. So this is 4. So this is an example how we use the fractional indices to calculations. So in this case here is necessary here to write this as a power, because I can also do the opposite. From this root I can make them as powers. This is very useful here. You remember the laws of indices. So in this case I can write this as 10 to the power of 9 times 3 to the power of 6, and I make this as a power of 1 over 3 because I have a cubic root. I can write this as a fractional power. And the other law I need to use here is I multiply the indices here. So it's 10, 9 divided by 3. I times everything by 1/3. So it's 9 over 3 times 3 to the power of 6 over 3. This gives you 10 to the power of 3 times 3 squared. So the answer here is 9,000. 3 squared is 9, and 10 to the power of 3. So this is 9,000. You may find another way of doing this, but this is one good way of presenting this. The other number here is 512 raised to the power of a negative 1 over 3. Something else with negative numbers, negative powers. If you have a power or a fraction a over b raised to a negative power of c, then you can find the reciprocal of the fraction b over a. The reciprocal is 1 over the fraction, so it's b over a to the power of a positive power. You can change this into this. So the reciprocal, you raise to the reciprocal of the number to the positive power. Reciprocal of a over b is 1 divided by a over b. 1 divided by over b. So in this case, because you have a negative power, you can write this as 1 over 512. This is the reciprocal of the number, and I need to raise this to a positive power, so it's 1 over 1 divided by 1 over 3. Because it's 1 over 3 is a cubic root, so I can make this under a cubic root of 1 over 512. And this gives you 1 over the cubic root of 512, and is 8, isn't it? This is 1 over 8, because 8 to the power of 3 is equal to 512. And this completes this exercise. And the final exercise that I'm going to do here is solving an equation when the power is x. Normally, if it's easy to solve an equation, a linear equation is very easy to solve, but when the x is a power, not a number, then we need a specific method. Now, if you see this exercise here, you have 2 to the power of 3x is equal to 1 over 64. In this case, it's necessary to use the method of equating powers, because the only way to find the value of x is to write the 64 as a power of 2 and compare the powers. This is the best way to do this. Now the 64, if you do the factor tree, you can see this is 3, you can write this as a power of 2. So it's the 32 is 2 to the power of 5. And then I have another 2 here, so it's 2 to the power of 6. So I can write this 1 over 64 as 1 over 2 to the power of 6. Now, because I need to flip the fraction, find the reciprocal, I make the power negative. And now I have a power of 2. So this is 2 to the power of 3x, and the other is 2 to the power of minus 6. Because I have an equation and then both sides are equal, the powers need to be equal also, because it's an equation. Powers need to be equal. And therefore, solving this equation now, 3x equals minus 6, I can find the value of x as 2, minus 2. And then I solve this exercise using this method. It's a very useful method when the power of x, when the x is a power and not a number, a multiple or addition of number. So if you have any question, you can leave your comments and I can answer them. So see you next time. Thank you for watching.